Double angle and half angle identities, section 6.6. So, once again, reminder, we have the sum and difference identities, and I claim that if you have the sum and difference identities, then you get for free the double angle identities, and we're actually going to derive those. And so, if I want to know what is sine of 2 theta, recognize that sine of 2 theta is the exact same thing as sine of theta plus theta. Therefore, it's the same as my sine of alpha plus beta, where alpha and beta are just equal. That's all. So, therefore, this is then going to be sine of theta, cosine of theta, plus cosine of theta, sine of theta. Well, remember that via multiplication of real numbers, we have commutativity, and therefore I can combine like terms, and this is the exact same thing as 2 sine theta cosine theta. And so I claim that if you want a nice double angle formula for sine of 2 times theta, that's just 2 sine theta cosine theta. If I want to find the double angle formula for 2 theta for cosine of 2 theta, well, once again, that's just going to be alpha plus beta here, where this is really cosine of theta plus theta, where alpha is theta and beta is theta. Therefore, I'm going to get cosine of theta minus sine theta sine theta. Well, cosine theta times cosine theta is cosine squared theta, minus sine theta times sine theta is sine squared theta. Okay, great. This is one good representation, cosine squared theta minus sine squared theta. But I claim that we're also going to use the Pythagorean identity to express it in two other ways. And so I remember that my Pythagorean identity is cosine squared theta plus sine squared theta is equal to 1. So I'm just going to solve for one and then solve for the other, and so that's going to give me that sine squared theta is equal to 1 minus cosine squared theta. And so that means another representation of this is cosine squared theta minus, and in parentheses, 1 minus cosine squared theta, which then I can distribute that negative. That's going to be cosine squared theta minus 1 plus cosine squared theta, which then cleans up to be 2 cosine squared theta minus 1. So that's another good representation. One last one, go back to my original box, and instead of replacing sine squared theta with 1 minus cosine squared theta, replace cosine squared theta with 1 minus sine squared theta. And then we'll get that this is 1 minus sine squared theta minus sine squared theta. And then combining like terms, this is then 1 minus 2 sine squared theta. 1 minus 2 sine squared theta is just another nice representation of cosine 2 theta. Then we can find one for tangent 2 theta. So once again, that's the same thing as tangent of theta plus theta, which is really then going to give me tangent of theta plus tangent of theta divided by 1 minus tangent theta, which then cleans up to be 2 tangent theta divided by 1 minus tangent squared theta. And so there's a good representation. So now let's just evaluate some of these. So given cosine of theta is equal to negative 2/5, and theta is trapped between pi and 3 pi halves, so really I'm just making sure that I remember what quadrant I'm in, and so because it's between pi and 3 pi halves, that's the theta. Now the good thing is that I can remember that theta, being in the third quadrant, all students take classes. If I'm trying to evaluate the double angle identity, I know that tangent's going to be positive, and so when I get sine of theta and cosine of theta, I better get a negative value. Well, not only do I need to do that, but I can use the fact that cosine of theta being equal to negative 2/5 creates this nice triangle. And so then I know that I have a negative x value, so that's going to be negative 2, and my radius is 5, and then I can find the y value via the Pythagorean theorem. That's going to be negative 2 quantity squared plus y quantity squared is equal to 5 quantity squared. Therefore, I get 4 plus y squared is equal to 25. Minus 4 from both sides, I get that y squared is equal to 21. Take the square root of both sides. I get that y is equal to root 21. Alright, then I know that sine of 2 theta is really going to be 2 sine theta cosine theta. So that's going to be 2 sine of theta cosine theta, which means that this is then going to be 2 times, well, what's sine of theta? Sine of theta is very specifically going to be root 21 over 5. Notice that I've made a mistake, and the mistake is that because I'm in the third quadrant, I know very specifically that the y also has to be negative, and so that's really negative root 21 over 5. Okay, corrected. Then times cosine of theta, but we found that that's negative 2 over 5. At this point, sine 2 theta is then going to give me negative times negative is going to be positive. 2 times 2 is 4. That's going to be 4 root 21 over 5 times 5, or 25. I should double check to make sure this won't reduce, but root 21 is 7 times 3, so it won't reduce. And so I claim that sine of 2 theta is 4 root 21 over 25. Well, then to find cosine 2 theta, the truth is if you wanted, remember we have 3 separate identities for cosine 2 theta. Pick your favorite one, it doesn't matter. But I'm just going to use the sum identity because I recall that this is really going to be cosine squared of theta minus sine squared of theta. And since that's the case, cosine squared of theta is really negative 2/5 quantity squared minus sine squared of theta, we just found that to be negative root 21 over 5 quantity squared. And then clean this all up, that's going to be 4/25 minus 21/25, or that's going to be negative 17/25, and that won't reduce, and so I claim we're finished. Sine of 2 theta and cosine of 2 theta have been found. Let's try another one. Given that tangent of theta is equal to negative 3/4, and theta is in the second quadrant, let's go ahead and make note of that. Theta is in the second quadrant. Find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. Okay, once again, these all go back to our picture. So I have my angle here, and then because I remember that tangent is really y over x, because I'm over here in quadrant 2, I know that my y value is positive, so that's going to be 3 over negative 4. And then I will have to find my radius, but I can find that by 3 squared plus negative 4 squared is equal to r squared. So then 3 squared is 9 plus 16 is equal to r squared. I get that r squared is equal to 25. Take the square root of both sides. I then get that r is 5. So I have r is equal to 5. So then if I want to find sine of 2 theta, I recall that sine of 2 theta is 2 sine theta cosine theta. Well then, what's sine theta? So this is going to be 2 times sine theta, but sine of theta is just going to be 3/5. Cosine of theta is negative 4/5. And then I get that this is negative 4 times 3, or negative 12 times 2, which is negative 24 over 25. So negative 24/25. Then if I want to find cosine of 2 theta, once again, any of the 3, but I'm going to use cosine squared theta minus sine squared theta. Well, cosine squared theta, that's going to give me negative 4/5 quantity squared minus sine squared of theta. So that's going to be 3/5 quantity squared. I then get that this is 16/25 minus 9/25. And 16 minus 9 is 7, so 7/25. Check to see if it will reduce, but it won't, so 7/25 is really cosine of 2 theta. Then, tangent of 2 theta. Tangent of 2 theta, well, that's just going to be 2 tangent theta divided by 1 minus tangent squared theta. And so honestly, this one, all the work's already done because I knew what tangent of theta was from the get-go. This is then 2 times negative 3/4 divided by 1 minus negative 3/4 squared. And so this gives me negative 6/4 divided by 1 minus 9/16. 16 minus 9, or 1 minus 9/16 leaves me with 7/16, so that's going to be negative 6/4 divided by positive 7/16. But then fraction division becomes fraction multiplication, copy dot flip, minus 6/4 times 16/7. 4 goes into 4 once, 4 goes into 16 4 times. I don't see any more reduction. This is then negative 24/7. There we are. Also recognize that you could have gotten negative 24/7 by taking sine of 2 theta divided by cosine of 2 theta, because tangent of 2 theta is really the exact same angle measurement. And so had you preferred to use the quotient identity to verify this, you could have. Now the half angle identities, we're not going to derive them. You would end up using some form or fashion of the sum difference identities to get here, but I claim that you get sine of x over 2 is equal to plus or minus square root of 1 minus cosine x over 2. Cosine of x over 2 is equal to plus or minus the square root of 1 plus cosine x over 2. Tangent of x over 2 is equal to positive or negative square root of 1 minus cosine x over 1 plus cosine of x. Notice that all of this is inside that square root. And there's some alternative ways to write that. That's the same thing as sine of x divided by 1 plus cosine of x, or 1 minus cosine of x divided by sine of x via some other identities. Now, how do we know if it's plus or minus? Okay. So the trick is that what's going to happen is, of course, if you know which region, which quadrant your theta angle is in, your x, then when you divide that by 2, you can figure out where half of those angles are going to lie. And if half of those angles are going to lie in quadrant 1, then you would take positive for everything. If it's quadrant 2, remember that all students take classes, and so you're just going to have to watch out to pick the pluses and minuses based on what quadrant your half angle would be in. So let's try this. We want to find the exact value of sine of 22/5. Well, we're talking about half angles, so my belief is that somehow or another this is sine of x divided by 2. Okay, well let's figure out what is x. Well, if x divided by 2 is equal to 22.5 degrees, multiply both sides by 2, and I get that x is really equal to 45 degrees. And so that means that this is the same thing as sine of 45 degrees divided by 2. Great. Well, then if we're trying to find sine of x divided by 2, where x is 45 degrees, recognize a couple things. 22.5 is in the first quadrant. And so since 22.5 is in the first quadrant, then I know that it's going to be positive. All students take classes is coming into play here. Well, then I know that my formula is sine of x over 2 is equal to positive or negative square root of 1 minus cosine of x divided by 2. But at this point, I can actually identify for this angle 22.5 which one is correct. Specifically, it's going to be the positive, because we know we're in quadrant 1 for that angle 22.5, and therefore it will be the positive one. So then I just plug everything in. This is then going to be the square root, so sine of 22.5 degrees is equal to the square root of 1 minus cosine of 45 degrees divided by 2. That's then going to be 1 minus square root of 2 over 2 divided by 2, all square rooted. Now if you're trying to clean this all up, then inside that radical, multiply by 2 over 2. That's then going to give me, this is the square root of 2 minus root 2 over 4. It'll clean up a little bit further, and that is, this is the square root of 2 minus root 2, but the square root of 4 is really 2. And so you could write square root of 2 minus root 2 over 2. And this is a perfectly good solution. Technically, there's nothing wrong with my original solution, but if they're picky about how we input it, we may want to simplify it some. So now let's find the exact value of cosine of 5 pi twelfths. Alright, well, where does 5 pi twelfths live? Well, 5 pi twelfths is just shy of pi halves, and so 5 pi twelfths lives here in quadrant 1. Okay, so this is 5 pi twelfths. Alright, since we live in quadrant 1, we know that when we're dealing with this value, it's going to be positive. But I still need to figure out, how can I rewrite this as some x divided by 2? Well, if I know that x divided by 2 is equal to 5 pi twelfths, then I can multiply both sides by 2, and I'm going to get that x is equal to 5 pi sixth. Okay, that's perfectly fine. So this then is cosine of 5 pi sixths over 2. And so then, using my half angle identity, I know that cosine of x over 2 is equal to plus or minus the square root of 1 plus cosine x over 2. But because we know that 5 pi twelfths is in quadrant 1, it's only going to be the positive. We can actually ignore the negative completely when we do this evaluation. And so then that's going to give us that cosine of 5 pi twelfths, being the same thing as cosine of 5 pi 6 over 2, is really then going to be the positive square root of 1 plus cosine of 5 pi 6 divided by 2. Since 5 pi 6 lives in quadrant 2, we need to know that cosine of 5 pi 6 is going to be negative, because all students take classes. So this is going to give me the square root of 1 minus cosine of 5 pi 6 is negative root 3 over 2, so it's really plus negative root 3 over 2, all divided by 2. I can clean this up a little bit by multiplying inside the radical by the common denominators of all the denominators of all the smaller fractions, and so then distribute this. This is then going to be the square root of 2 minus root 3, all divided by 4, but then that will clean up as the square root of 4 in the denominator is 2, and so this is really the square root of 2 minus root 3, all divided by 2.